This time we're using the definition of the derivative as a function, the general definition of the derivative. We'll recognize this type of question pretty quickly because of the hitch. Okay, so the hitch is a dead giveaway as to the type of problem this is. Now we can do it, and we will do it by L'Hopital's rule, and that's absolutely fine as well. But let's see how we would do it using the definition of the derivative. First of all, again, the definition of the derivative, as you know, is that the limit as h approaches 0 of f of x plus h minus f of x all over h is equal to f prime of x. Okay, so if we compare what we have in the original question to the definition of the derivative, it looks like this. F of x plus h, just by comparing the relative positions of these things, f of x plus h would be equal to the log of e plus h. F of x is equal to 1, and that would mean f prime of x, because it looks for all the world like x and e have swapped places, so f prime of x would be f prime of e. So in other words, what we're saying is that this is f prime of e. Okay, f prime of e. Now, it makes it a little bit more difficult to do it this way. So there is a shortcut. So let's start again. That's just setting it up and comparing the question to the definition. So let's use a shortcut for this problem and for all subsequent problems of the same type. So the limit as h approaches 0 of the log of e plus h minus 1 over h. Okay. Well, the first thing we have to figure out, we know we're trying to find f prime of e. The first thing we have to try and figure out is what f of x is. And to do that, we're going to block off the piece that's added on to h here at the start. Okay, so we're just going to block off the piece that's added on to h here at the start. And then whatever is being done to the hitch, that's our f of x. So in this case, f of x is the log of x. Okay, now we're talking about x now. Whatever has been done to the hitch, that will give you a clue as to what f of x is. So we're getting log of hitch, and that means f of x is log of x. So we differentiate that. Okay, we differentiate that. That gives you f prime of x is equal to the derivative of log is 1 over x. And then the piece that we erased, okay, the piece that we erased, this e in here that we erased, that's where we're evaluating the derivative. And we'll check just to make sure that it's the same as we had previously up here. That's where we're going to evaluate this derivative. So we're going to actually find f prime of e is 1 over e. And that is the question solved. Okay? The limit of the log of e plus h minus 1 over h is actually asking us to find the derivative of the log of x when x is equal to e. It's a little bit strange, but that's what it comes down to. Now, let's do it by L'Hopital's rule. Okay, so let's do it over here by L'Hopital's rule. And again, in an exam situation or a pressure situation where you're worried, L'Hopital is absolutely fine to go with L'Hopital's rule. So, remember, the first thing about L'Hopital is that you have to get 0 over 0, or infinity over infinity, I guess, as well. But it's mainly going to be 0 over 0. for these questions. So under substitution, so that would be the log of e plus 0 minus 1 over 0. Well, the log of e is 1, so that would be 1 minus 1 over 0, which is 0 over 0. So that means the indeterminate way is the way to go. Now, the limit as h approaches 0. We're going to differentiate the top and the bottom with respect to h. Okay, we're going to make h is our variable here, so we're differentiating with respect to h. So if we differentiate the top, it's log, well, that'll be 1 over e plus h. Okay. Now, minus 1 is a constant, so the derivative of constant is 0. And on the bottom, the derivative of h is just 1. And remember, h is our variable. So this is simply the limit as h approaches 0 of 1 over e plus h, which is, after substitution, 1 over e. And again, two answers coincide, as they'd have to. Now, again, whichever method you like to use is the one that you should use in an exam situation. I'll keep stressing that to you. You're not required to do one way or the other. But it's important, I think, for your own development as a calculus student and as a mathematician, that you take some time to try and recognize the limit form of the derivative. Okay, so best wishes with that. Okay, thank you.